The last build is the most intense and mathematically complicated. A level with a clock needle that points where the hub is tilting. We can program this using the hub's internal gyroscope through the motion sensor module, which has a function which returns the yaw, roll, and pitch from the hub. You may also recognize the clock images from an earlier challenge being used to represent the needle. Now, this is a hard one, so I'm going to give hints in 2 stages. If you just want to sink your teeth in, pause the video here and get to work. Here's the first hint. We can think of the pitch and roll as being on the X and Y axis respectively, and the tilt of the hub as being a point on that plane. From here, we can draw a line from the point to the origin and show the direction that the needle should point in. What mathematical functions could we use to find the angle between pitch and roll? Pause the video and I'll let you think. It's arctan, or the inverse of tangent. Once you have that angle, you should find some way to translate it to the appropriate clock number, which I recommend should be its own function. Pause the video here before I give you another hint. When you get the arctan of roll and pitch, it should return the reference angle, meaning that you can never see it outside of the first quadrant. But your program will have to handle cases where your hub is tilting everywhere. There are many ways to handle this, but you could start by taking the direction of the roll and pitch, and somehow using that to determine the quadrant you're in.